And good night, everyone. I'm Flavio. I'm going to present this article entitled An Innovative Method to Extract Data in a Real-Time Data Warehouse Environment. This article was written by me, Flavio Assis, and my PhD professor, Ricardo Rodrigues. We are from Brazil, São Carlos. And in this presentation, firstly, we talk about a slight introduction in traditional DW and E2L process. And after that, I will present a new trend and demand of a real-time data. And so I will present an innovative method to extract data in a real-time data warehousing environment called data extraction magnet, or DAM. I will, I will talk in the next slides as DAM. And finally, I will present the experimental test and conclusion. Firstly, I will talk about the two main components that compose the whole data warehouse environment. The first one is operational environment that is composed of heterogeneous data sources and systems. This operational environment is responsible for inserting data by a group of users into the heterogeneous data sources. And on the other hand, we have a data warehouse environment that is composed of tools, algorithms, and technologies. And the main components of this environment is a data warehouse repository, or DW. This repository is characterized by being a constant, integrated, and homogeneous data sources. And this main focus is on decision-making process by all of periods. These two environments need to be updated in a predefined moment. The DW repository needs to be updated, and this updating process is performed by ETL process. Extract E, transform T, and load L. This updating process is performed by the ETL process, and this process is characterized by extract data from operational data sources, transform this data into a homogeneous format, and load this data into a DW repository. This ETL process is performed in a predefined mode, as I said, and as the in recent years, as the time goes by, a new trends and demands of a system has emerged, and the need of updated data as fast as possible. This is because mainly this some systems makes use of sensors, and these sensors produce a huge volume of data in a faster time. And these new trends of type of applications, I can example here healthcare systems, road traffic systems, smart farming systems, smart city systems, and so on. All these environment, all these applications are composed of sensors that produce data. And all this environment is characterized by should to respect the requirement of a real-time environment. Example here: availability, scalability, and low response time. All these three characteristics needs to be respected when someone proposes some techniques, methodologies, or architecture or studies in a real-time ETL process. Uh, the biggest problem to apply ETL, traditional ETL process in this environment, that is the data produced into a operational environment, produce a huge volume, and in a faster time, and in this moment can cause a huge overhead in the sources from operational environment. On the other side, we have the DW repository, and as well, and in this moment, in the same moment, can serve another group of users that is making some a lot of queries. And we need to propose some techniques, another techniques to perform ETL process in this type of environment. Many attempts to perform the ETL process in a real time has emerged in the recent years. For example, two main approaches has emerged in the recent years: a near real time and on demand. The basic idea in these two approaches is increase the frequency that the ETL process performed in the environment. For example, once a day, instead of perform this ETL process once a day, we can perform this ETL process twice a day, 3 times a day, or depending on the updating roles of the business. And even so, it is not enough to perform ETL process in a real time to meet the real time requirements, because as I just said, the operational environment is busy, by the users writing data into the data sources. And on the other side, we have the DW repository serving another group of users that is performing a lab accuracy. In the sense, we have here now the data extraction magnet, a new innovative method to the extraction phase of ETL process in a real-time data warehouse environment. And uh, to develop this method, we introduce some concepts that that different from previous work, never had been used into a real-time ETL process concept. The basic idea of our method is the coupling ETL process and operational environment. Instead of we need to access directly access the operational environment to get data, to gather the data, we develop this method just to receive data and not to to connect and get data from operational environment. And this main different of the main difference of our developed method to traditional ETL process is just to receive data and not access directly the operational environment. To do this, for this purpose, we use the following characteristics. The, the, the first one is metadata management. By means of this metadata, we can make the ETL process the coping from operational environment. The administrator users can define some metadata that I will show you later. And this metadata, once configured, the data extraction magnet can perform the phase of extraction of ETL process automatically. By means of tag or data of interest, we can assign we can assign a data of interest from operational environment and make this data available from this make this data available from operational environment to data extraction magnet. The tag is an indicative that data that is produced into the operational environment has an interest to DW repository. And by doing this metadata configuration and tagging, we can improve the ETL process, and we can reach the two following characteristics. Non-intrusive, that is, we cannot access directly the operational data sources. Instead of this, we can receive the data. Once received, the data extraction magnet can react automatically and detect which is the DW that has interest in store this data that arrive from operational environment. To aid all this process, to aid all these things, we make use of publish-subscribe system. Basically, publish-subscribe system is composed by three main components. That is publish, that produce data from one environment, subscribe, that consume the data on the other environment. And between these two environments, between these two components, we have the broker. The publish side produce data and public this produced data into the broker. At the same time, subscribe side connect to the broker and establish interest of receive the data. These pub subsystems that we used is useful to aid us to receive data from heterogeneous environment, and on the other hand, aid us to send this data from another heterogeneous environment. And that is why we use pub subscribe system. And to aid the performance concepts, we made use of buffer and parallelism. Then this figure, from this figure, we can yes, okay. This figure show the basic architecture of data extraction magnet. To begin this explanation about this figure, we can hear three main components: management environment, operational environment, and ETL process, and pub subsystem for main components. Firstly, I will talk about this repository component. This is a metadata repository that store metadata that is configured by the administrator users. Here in repository, the tags repository should store the name of tag that the administrator users has defined. And once configured, we can assign this tag that is configured here into, we can assign this tag in a data of interest from operational environment. For example, in a relational database from operational environment has a table named, for example, student, and inside this table, student has a field named name, for example. This data of interest name can be assigned as tag, for example, student. Okay, and in this time we have a data of interest assigned together with a tag. And in this moment, data extraction magnet knows that this data has interest from data extraction magnet. And once operational environment send this data to ETL process, we can detect automatically which tag has interest from data of interest from operational environment. Continue here. We have here later. I will return to this component to better explain the whole flow, the workflow of the data extraction magnet. Continue here. We have operational environment that is just abstraction of representation of an operational environment that is composed of a source 1, source 2, source 3, and so on. We have here pub subsystems, and we have here a ETL process. Okay, once operational data source send some data of interest to broker pub sub. The data of operational environment should to connect to the pub subsystems and is ready to send data from this to this broker. And at the same time, the data extraction magnet, that is this whole thing here, connect at the same time. This data extraction magnet connect in the same broker and establish an interest to receive the data that is sent by the operational data sources. Once received the data extraction magnet is composed of a listener component that is responsible to listening the broker and receive the data that arrive from operational environment to the broker. Once received the data, the listeners send this data to validate the process. This validate process is responsible to access the repository components, as we see here, tags repository and sources repository. Just to once connected this to this repository, the validate process is responsible to validate this data of interest. Why does we validate this data of interest? It's just to detect the tag that is assigned to this data of interest that is arrived from operational environment, just to detect the tag. And once detected, we should to put this validated data and this tag, the tag that is seek here, to the buffer management. The next time that this same data is received from operational environment, this validated process is performed just in buffer management and we do not need to access the repository, because these characteristics can be improve our performance and as well as the scalability of data extraction magnet. And once validated, this validated data is sent to the send data. This send data store the data of interest that has now a tag assigned to this data of interest and is ready to be sent to the rest of the phases of E2L process. And as we can say here, by doing this strategy, by doing this method, we can decoupling the operational environment and the E2L process. E2L process, by means of data extraction magnet, is ready to receive data from operational environment, and we do not connect into the operational environment to get data. Okay, and here we have an experimental evaluation to test this data extraction magnet. This data extraction magnet was validated in a dye-defined domain, and it was driven synthetically. Uh, this this experimental test is driven by a synthetic data generator system that we have developed just to generate data that is that is that has the same properties of a real-time data, but we can control the volume and the frequency that the data is generated, okay, by this synthetic data generator. And we expected here to validate the requirement of real-time environment that we said before. Just to recap, availability, low response time, and scalability. And we validated the performance of data extraction magnet against the performance of trigger technique. By means of just to comment here, just to highlight here, we have we made a systematic review of a ETL process applying in a real-time environment, in a real-time data warehouse environment, and we can realize that the trigger technique is considered a state of the art of the ETL process. In this moment, we should test our data extraction magnet to the state of the art of the extraction phase of the ETL process, and we consider this trigger technique. Okay, the next three graphs we show here. In a dark blue, we have a DAM or data extraction magnet. In a light blue, we have trigger technique. This graph is composed of six measures: mean value, P50 value, average, P95, P99, 99, max value. This all value this value is a response time of the experiment. As we can see here, just to recap here, this first test is 32 sensors sending data from 250 calls parallelly. And the following graphs we will show this sensor, this volume of sensor and this quantity of calls will increase, and we will show that a data extraction magnet can be better than trigger technique. Okay. And just to highlight here, for example, P50 for data extraction magnet is 0.471 seconds, whereas this same measure from trigger technique is 1.913 seconds. We have here a great performance of data extraction magnet. The average measure of data extraction magnet is 0.529 seconds, whereas the same measure of trigger technique is 3.873 seconds. Just to continue here, for example, here, P99, 99 from data extraction magnet. This value is 1.285 seconds, whereas this same measure of data of trigger technique is 12.43 seconds. As we can see here, data extraction magnet can result in a great performance gain in comparison of trigger technique. In another graph here, we have 63 sensors sending data from 500 calls parallel. In this, we use the same measures, okay? For example, P50 for them is 0.486 seconds, whereas this same measure of trigger technique is 3.81 seconds. For example, here, average measure from them is 0.859 seconds, whereas the same measure for trigger technique is 5.73 seconds. And finally here, for example, P99 for them is 13.028 seconds, whereas the same measure for trigger technique is 20.071 seconds. And finally here, we have this graph. 125 sensors sending data from 1,000 calls parallel. As we can see here, we have a huge volume that the ETL process needs to manage parallelly. Okay, and as you can see here, P50 for them is 0.471, and whereas the same measure for trigger technique is 1.913 seconds. This say continue here, the average for them is 0.529 seconds, whereas the same measure for trigger technique is 3.873 seconds. As you can see here, data extraction magnet has a has a good performance, has a great performance, and has a great performance gain in comparison of trigger technique. This we can we can assign this good value by means of the whole things that we introduce, the whole concept that we introduce into the concept of ETL process. And as you can see here, some values out of the pattern, as the dam as the trigger technique. Here we have this value of out of pattern. This we have this value of the pattern. The max value, okay, we can see. This is the we can strongly see here in a max value here in this graph as well. This we can attribute this value of the pattern because the implicit overhead that is introduced in this environment. For example, in this environment is composed of a pub sub system. In we use the internet to aid this all this experiment. And in this way, we expect, we hope that sometimes we have a poor internet connection, or we expect some delay in the internet connection, and that is why we consider this value of the parent. Uh, we consider implicit overhead to increase this max value. But we can note here this is a tiny quantity of the whole of all records that we collected from the experiment. Okay, it is a tiny quantity of volume of the all data. And in conclusion, uh, in this night we present and the data extraction magnet, a new innovative method to extract data from operational environment. The main idea of our developed method is the coping ETL process and operational environment. To do this, for these purposes, we consider the following characteristics and the following concepts that never had introduced into the ETL process concepts. This concept that we have introduced is tag, non-intrusive reactive metadata management, publish subscribe systems, buffer and parallelism. Parallelism. Publish subscribe system, buffer and parallelism. Uh, some works use these three main concepts in the layer works. But tag, non-intrusive, and reactive, we these three main concepts never have been used in the layer from in the recent years from the works that approach the ETL process in a real time. And by means of this experimental test, we could show a great performance of data extraction magnet and a great performance gain of data extraction magnet against trigger technique. And for future work, we intend to extend the performance test in a real case study. We intended to build an innovative way to store data of interest, the same data of interest, into a target data warehouse, and we intended to investigate another metadata to be applied into the context of storing data of interest into a target data warehouse. And it is all for tonight. It is all for today. Thank you for your time.